This is the same idea or the same whatever philosophy, I guess, if you will, as yesterday, where, again, in my opinion, there's not a lot of math today. It's more just remembering what things mean and what we're looking for and how to represent things and vocab type stuff. So I'm hoping that for most of you, I also just thought of, and I'll have to look at the other chapters to see, but I think we're now reaching the time in Algebra 2, and it should be good news for you guys. I guess maybe not. But on the last chapter, that does not mean you're going to get on this chapter. Like for a very long time with math, chapter 1 includes chapter 2. Chapter 2 involves chapter 1. Basically, it all builds on itself. The stuff you learn in chapter 1 helps you with chapter 2. The stuff you learn in chapter 2 helps you with chapter 3. But then once you get far enough in to Algebra 2, now all of a sudden, if you were very good with radicals, that's okay. There's no radicals in this chapter, not any of them at all. So if you're one of those people that didn't do very well on the test, which, by the way, I will finish grading. We're doing test corrections tomorrow, so I'll have it graded by tomorrow. I think probably. But if you didn't do very well in the last chapter test, that does not mean you're not going to do well in this. You can still pick yourself up. You can still make sure you understand this stuff. So enough of that motivational speech. So the first thing we're going to learn is the vocab word relations, and we won't, obviously, we won't talk about this very much. We talk about functions way more. Relations are when we have sets of inputs and outputs. Now, the difference between a relation and a function, we'll talk about this later. A relation is just any inputs and outputs. A function has exactly one output. Whatever input you put in, it has one and only one output that comes out. So a relation is just whatever numbers. Once we learn about the function, you'll see what we talk about that. There are 4 different ways to represent relations, or I guess there's 4 different ways that we're going to focus on. You could just write them out as ordered pairs. And I put this in here, but the inputs are your x value, the outputs are the y value. You could also do a mapping diagram, which is similar to the ordered pairs. The only difference is you only have to write down everything once, and then you just draw branches. So, for instance, these are all the same ordered pairs. So, -3, 4, we have -3, and that draws a line to 4. 3 goes to -1, so we connect 3 to 1. And then 4 goes to both, -1 and 3, so we have 2 branches coming out of that. So that's what a mapping diagram is. Again, you don't use it super often, but it does exist. The next one is a table of values. You guys have seen this already. That's when we make our T charts. And the last one is a graph where you just list those ordered pairs. Sorry, I was looking. Oh, interesting. Okay. So, we're going to talk about very briefly just how to make a mapping diagram, table, graph, so on and so forth, and the domain. Honestly, we don't talk about the ordered pairs a lot because that's how I usually ask the question. So I'll give you this list of ordered pairs. I want you to draw a mapping diagram, table, graph, then we'll talk about domain and range. Don't make these harder than they are. Mapping diagram, the first box is your input, so it's all your x values. Mapping diagram, you don't want to do any repeats. So if you have a number that happens twice, you want to not do that. Now, I will also say, normally speaking, if you want to be absolutely correct with this notation, you should go in a numerical order, so your lowest number first. I'm not finicky on that. But I am a little bit finicky on that you have to make sure you don't write 0, 3, 3, 2, and then I have 0 again. I write down to 0 twice. Because we'll have 2 different branches coming out of that first 0. So left-hand side, that's your inputs. Then your outputs are the other side. We have 2, 4, -2. Don't go 4, we already put that one down, and 1. What you need to do is you draw lines, and they do not need to have arrows. If they don't have arrows, they do not have to. You just connect. 0 goes to 2. 3 goes to -2. 2 goes up to 4, so that goes up to 4, and then 0 goes to 1. So again, now we go back up to 0 and draw a line down to 1. So that's your mapping diagram. I personally think that's the hardest one because it's new. We haven't done that a lot. You really have to just remember you don't have your. Well, don't make this harder than it is. literally list out your ordered pairs. 0, 2, 3, 4, negative 3, negative 2, 2, 4, and 0, 1. And lastly, again, you should be very proficient at this graphing by now, but the x is left and right, the y is up and down. So if my x is 0, I go left and right 0. My y is 2, I go up 2. So 0, 2 is right here. 3, 4, negative 3 down 2, 4, and over 0 up 1. Diagram, the table, and the graph. Again, you should be. One of the reasons I thought about not teaching this lesson, basically because I figured you probably knew some of this stuff, but also, I guess I should say the other way around. One of the reasons I decided to make sure I go over this section is so I can put some of these questions on the test that hopefully are easy questions for you. At least that was my intent. So if you're not comfortable with the table and the graphing, make sure you ask. So, last thing then, we're going to list our domain. Now, it's the same thing we did yesterday with our domain range. The only difference yesterday, it was a solid line. And so there was an infinite amount of those domains. You could have 2, 2.5, 2.75, 2.756, 2.758. There's infinite. And so that's why we put a range. That's why we said it's in between -2 and 5. Well, now we have specific points. So for your domain, all you need to do is list out your x's. For your range, all you need to do is list out your y's. Technically, you're supposed to have what they call a brace in front. If you don't know how to draw brace, you just like try to draw parenthesis, but like bump your elbow a couple times on the way down. It doesn't have to look good. And honestly, again, I'm not super finicky on that notation, but that's what that brace is. You list your x values. Now, again, very similar to the mapping diagram. The biggest thing is you don't want to do any repeats. If you do that, half point off, not a huge deal, but you don't want to miss half point on this stuff. So don't put any repeats, but then again, you list them, and again, it technically is supposed to be in numerical order, but I'm not going to be super finicky about that. Basically, I tried to decide, should I have a nitpicky on the order or on the repeats, and I decided to be picky with the repeats. So, if you look at your order, we have 0, 3, -3, 2, and we don't have we already have 0, so we don't need to list that down again. For your range, you do the same thing. 2, 4, -2, we have 4, we already have that, and then 1. Whoops. It's terrible, but that's good enough. Again, not super. As long as it doesn't look like a 3, that's my problem. Sometimes I accidentally make it look like a 3. So, again, that's how you do it with, don't give you ordered pairs, but it's even nicer, in my opinion, especially the mapping diagram is nice because you already don't have repeats. So if you do a mapping diagram or if you see a mapping diagram, you literally just have to list this is your input, your x's, your domain, this is your range. Just make a list. Your table way where this is your domain and range nicely, but just make sure you're careful of those repeats. The 0s over here to 4s. And then if you have a graph, I think it's a little bit more complicated. Honestly, if it were me and I had a graph, I'd be a little bit tempted just to make a table. But again, if you wanted to, you just list all your x's, so like -3. Make that easier because the repeats are a little obvious. -3, 0, 3, and then your y values, -2, 1, 2, and 4. So you can do that one as well. So the next two on your own, real quickly, write the domain and range for the two relations. I'll give you guys about a minute to do that. Domain and range there. For those two, again, that graph, if you're confused at all, if you just list your ordered pairs, that takes a little bit longer. Again, I guess the easiest way to do it is, I would do it systematically, so I would start left to right, just because that's kind of how you regress anyways. There's a point here at -3, there's a point here at 2. You can almost imagine like you took a piece of paper and slid it across. vertically, you can see -3, -2, and then 1, 2, and 5, and then same thing from bottom to top. Again, I don't actually care the order, so if you want right to left or top to bottom, I don't care. But you can do it that way, or again, if that's confusing at all, just take the time to list out the ordered pairs. I've had students that they're really good with the ordered pairs, but they're not good with graphs, and I never understand why I don't take the extra 30 seconds to just make your ordered pairs or your graph into ordered pairs. Okay, so I know you guys were all on the edge of your seat when I talked about this earlier today, but now we're going to talk about functions. So functions are a relation where every input has exactly one output, and that's very important in math, because in math, if you said 2 times 3 was 6, and I said, well, but sometimes it's 8, that'd be really confusing. When do you put what? So that's the whole idea with math, is that if you put something in, you definitely only get one outcome. For me, when I was trying to think of examples of things that were not functions, I literally couldn't think of any. I mean, you can't think about math because all of the stuff I think of math is a function. But if you can think about, I mean, this is a stupid example, but if you give a horse a carrot, sometimes it makes them sleepy, sometimes it makes them run around. There's 2 different outcomes with 1 input. But our function, for every single input, it only has 1 output. Now, again, there's different things we'll talk about once we see these diagrams that will talk about the outputs. But the inputs, each one has to go to 1 output. Only 1 output that works. So the ones that I listed out, the 4 things we're looking at, I just did a quick thing that, to show you what you can look for. So if you're dealing with tables or ordered pairs, look for your x's. If there are any repeating x values, then it's going to be not a function. It doesn't matter if the y's repeat. So the y's, you can have the same y value every single time. So you can have ordered pairs where it's like 1, 10, 2, 10, 3, 10, 4, 10. You have as many 10s as you want. It doesn't matter what the y's do, just the x's. If the x's repeat at all, if there's any x that happens twice or more than that, it's not a function. For a mapping diagram, if you look at the inputs, there's only 1 branch coming out of every input. And again, I even specified that's the one on the left. So if your left-hand side, there's only 1 of every single one of those. It is a function. If there's any of those points that has more than 1 branch coming out of it, then it's not a function. Now, again, we don't care about the right-hand side. It doesn't matter what that right-hand side looks like. We're only looking at the left-hand inputs for that. And then graphing is the vertical line test. We'll talk about that here after we do these couple problems. Say whether the following are functions or not. Again, the mapping diagram, I literally, and don't actually do this on your paper, but we don't even have to think about this output. We don't care what that looks like. Look at your inputs. Are there any of those that happen or that have 2 branches coming out of them? Yeah, the 0 goes to 2 places. So that means this one's not a function. This also has 2 branches. We don't care about that. We only care about if there's 2 branches coming out. So for the 0, remember it says only 1 output. Does it go to -2 or does it go to 1? It goes to 2 different places, so that's why it's not a function. But again, it's easier with a mapping diagram just to look on that left-hand side. Next one, the table. Only look at the x's. Are there any of those numbers that repeat? No, so this one is a function. Again, every input only goes to 1 output. The -1 only goes to 5. The 2 only goes to -2. The 5 only goes to 0, etc. Now, I think ordered pairs are the hardest ones, and it's mainly just because it's not organized super nicely, so you just have to go through and make sure you're being careful. I, a lot of times, do this where I underline my x's. Are there any of those x's that repeat? Yes, the -2. So, -6. -7 goes to -1. 5 goes to the 0. But what does -2 go to? Well, it goes to both a -5 and a 4. That means it's not a function. You cannot go to two outputs from 1 input. And the next one, again, you're only focusing on these x values. -2, 0, -3, 3, -5. They're all input repeats, so that one is a function. And lastly, again, hopefully you guys picked up on this by now. But again, I've had people that miss this all the time. If you look at this left-hand side, everyone only has one branch coming out of it, so it is a function. But the thing that people miss all the time is they see that two branches go into the 4. That doesn't matter. We don't care about that. I don't care how many numbers you plug into the equation that you get 4. Every single thing you plug in gets one definite answer. Any questions on that before we move on to the vertical line test? So the vertical line test is the most popular thing that people probably remember from this. And it is a theory where it's a relation is not a function if at any spot the vertical line hits it more than once. And that's kind of a weird, I tried to describe it, but it's one of those things that it's a lot easier just to look at it. So if I took a straight vertical line, you can imagine taking a straight vertical line like this, and through this function, function once, anyway, there's still places that hit more than once. Even when it gets really steep right here, if you kind of look at it, it's only going to hit once. So that's why that one is a function. This one's not a function because it only takes one spot, but all these spots over here hit way more than, or hit twice. You hit twice, you hit twice. I guess there's maybe a point over here hit once, but it doesn't matter. At any point in the graph it hits more than once, it's not a function. So if you look at the two examples we have, this first one is a function. Again, if you draw a vertical line just about anywhere, it hits more than once. And this one is a function. No matter where you draw your vertical line or where you drag that vertical line across, it only is going to cross once. So this one is a function. Other schools I taught at had a really nice smart board, and I could draw a vertical line, I could click it, I could cross and show you. It was a really good visual, but that's kind of how you can think of it. If I could take this line right here and drag it across, if it ever hits more than once, it's. And that doesn't only apply to these types of graph. If you go back to the graphs we did earlier, this one is a function. Make sure you can see this one. This one is a function because all these vertical lines only hit once. There's one we just did. Oh, this one, the graph we made, is not a function because right here it hits twice. Over here is once. These are once, but it only takes one spot in your graph. So even if it's not a continuous graph, it's a lot of ordered pairs or points, you can still do that vertical line test. Now, this is a little bit out of the blue, but in my opinion, this is the most important part of this lesson, is understanding the reason why they put f of x and the reason they put f of 5. I'm assuming that when you guys were back in either 7th or 8th grade math, when you started learning that they gave you an equation that said f of x is equal to 3x, and your teacher said, well, just change that to a y. And a lot of guys are like, well, if I have to change it to a y, why didn't they just put a y? Why do they need to do the x? And I'm assuming you were on the edge of your seat for years and years, and I'm going to solve this problem for you. The reason we do that is we're labeling a couple different things. We're saying what our variable is. We're saying that we're plugging in the numbers for the x. But the reason we're labeling it an f is because you could have problems that have more than one function. So that's what we're going to talk about here in a second. If they tell you what is f of 5, we did this yesterday with our graphs, they tell you that the x is equal to 5. Well, the x is equal to 5, you just plug it into this. So we have 2 times 5 plus 3. That's 10 plus 3, that's 13. If you put that as your answer, that's absolutely fine. Honestly, again, I'm not going to fight that battle. But technically, the best way to do it is to label f of 5. Oops. Is equal to 13. And the reason that's really nice, and I probably should maybe write it like that, maybe next year I'll change my mind. But it's nice because in this one little phrase, I know what function I use the f function. I know what my input was, it was a 5. And I know what my output was 13. If you just have y is equal to 13, you don't know what equation you use, and you don't know what you plug in. So this is nice because I know all that. And what the output is, all in one slide. So now you'll have problems like this. I think actually on your worksheet, I maybe put something like this. But you'll have problems that at the top it says, this is my f of x function, this is my g of x, this is my h of x. So that here where it says f of 4, it's telling you you're plugging in 4, but it's telling you which equation to plug it in for. So if you plug in 4, that'd be 3 times 4 is 12. The next one, f of 6, again, you're just plugging 6 into your f equation. That's 3 times 6 is 18. But now the next one says g of 10. So now we're using the g equation. So we're using this one, and you're plugging 10 in. So you plug 10 in. 10 plus 5 ends up being 15. H of 16, again, it's telling you what equation to use. You're using your H equation, and you're plugging in 16. 16 divided by 2 is 8. And it's a pattern. So we have G of 4, 5 is 9. And H of 6 is 6 over 2 is 3. That's why it's really nice to use the notation f of x and f of 10 and all that. Because again, like I said before, it gives you 3 pieces of information. It tells you what equation you used or what function you used, what you plugged into that function, and what output you got. I used to ask questions where I'd say, write those as ordered pairs, and you just have to write 4, 12, 10, 15, 4, 9. So they are a little bit like ordered pairs, or very similar. And actually, I'll have you guys do these. I've given you the function, so it's not, you don't have to figure out kind of which function to use. But I'm going to give you about a minute to do both of those. It shouldn't take super long. Use your calculator. You do have an exit ticket today. It is not a win exit ticket, but I'll put the answers to this up here in a second.